Again, good morning, everyone. Um, I will be your teacher for Science 7. I am Sir MJ. You just call me Sir MJ Reyes because we have other MJ, of course, Sir MJ Ngalot. And by the way, our topic for this morning is wait, someone is in the waiting room. Is all about how to handle a microscope and how to operate the actual microscope. We'll wait for Labanan. Okay. Again, turn on your camera.
Hey, who are you? I said, who are you?
Please turn your mic in mute. Right. Shall we continue? Right. And please turn your mic on mute, Miss Labanan.
I said, who are you?
All right, let's continue. Again, I am your teacher for Science 7. I am Sir MJ. Shall we continue? As what I had observed also, some of you didn't actually participate or didn't, you know, take your activities seriously. Again, I am really serious with your grade. At the same time, I am really serious with science. And hopefully you're doing so also. I want you also to participate. Like, I want you to ask questions every now and then with the topic so that I can gauge if you really know the topic or you didn't understand the lesson yet. Am I making that clear? Hey, anyone? Am I making that clear? Okay,
Yes.
that's good. So let's continue. Okay. Introduction to microscope. Are you familiar with your microscope? Have you tried using your microscope? Anybody? You didn't try it yet?
No.
Oh, right. We have microscope at school. I will let you use the microscope when the scenario comes to normal or back to normal. So let's move to the topic again. Introduction to microscope. I am your teacher, Mark J. Reyes. You can call me Sir MJ. What is a microscope, by the way? A microscope is an instrument used to see objects that are too small to be seen by naked eye. Again, please ask questions. Please tell me if I'm too fast. And again, you can interrupt anytime. All right? Am I making that clear? By the way, talking about your activities, again, I had observed that only few of you are actually taking the activity, meaning to say that only few students also can actually again can have the grade. I cannot give the grade if you don't have an output. All right? Microscopy is a science of investigating small objects and structures using such an instrument. Microscopic means invisible to the naked eye or an eye unless aided by a microscope. There are many types of microscope and they may be grouped in different ways. By the way, can you see this shared screen? Grade 7, can you see the shared screen?
Yeah.
Yes.
All right. One way to describe the way instruments interact with a small or sample to create images, it's either by sending a beam, light, or electrons to the sample and its optical path, or by scanning across a short distance from the surface using a probe. The most common microscope, the one that we actually use in the laboratory, in the science lab, is the optical microscope, which uses light to pass through a sample, produces an image or produce an image. Other major types of microscope are the fluorescence microscope, the electron microscope, transmission. This is both transmission and scanning, and various types of scanning probe microscopes. Okay, let's move now to the types of microscopes. By the way, have you seen your microscope here in school? Did your previous teacher let you see the microscope when you were still in grade 6? Anybody? Oh, it's horrible. Okay, let's move now to the first type of microscope. We have simple microscope. The simple microscope is generally considered as the first microscope. It was created in the 17th century by Anthony van Leeuwenhoek, who combined a convex lens with a holder for specimens, magnifying around 200 and 300 times. It was essentially a magnifying glass. By the way, do you know Anthony van Leeuwenhoek? Hello, are you still with me? Again, class, I am not fan of students that are really passive. Okay, just to be honest with you, I want you to participate because I am doing this for you, not for me. I know this already long time ago. All right. Again, Anthony van Leeuwenhoek discovered the cell. He accidentally discovered the cell by looking at a dead cell of a plant through a bark. So he accidentally discovered a cork and he coined the name cell because it looks like a cell or a room, an empty room. While this microscope was simple, it was still powerful enough to provide Van Leeuwenhoek and information about biological specimens, including difference in shape between red blood cells. Today, simple microscopes are not used often because the introduction of second lens led to the powerful compound microscope. Today, we are using compound microscope in the laboratory. So this is an illustration of a microscope, no? A simple microscope. It looks like a magnifying glass. It just magnified your specimen in the limit of 300 times. Compound microscope. These are the common microscope we're using in our laboratory. With two lenses, the compound microscope offers better magnification. Someone's in the waiting room. Better magnification than a simple microscope. Yes, correct. The second lens magnifies the image of the first. Compound microscopes are bright field microscopes because compound microscope, it's either light compound microscope, which uses a mirror for illumination, or an electric microscope, which uses a bulb or illumination, meaning that the specimen is lit from underneath, and they can be binocular or monocular. You see, binocular, we have two, what? Two ocular. Okay? What is ocular, by the way? When you say ocular, from the root word ocular, grade 7, anybody? When you say ocular, this is an area where you can actually see. Okay? Monocular means 1. Binocular means 2. These devices provide a magnification of 1,000 times. Correct. Which is considered to be high, although the resolution is low. This high magnification, however, allows users to take a close look of the objects too small to be seen by naked eye, including individual cells. Don't worry. Hopefully, if everything go back to normal, I will let you see the actual specimen under microscope. We have prepared slides, and again, these prepared slides are already mounted so you can directly see your specimen in the microscope. This high magnification, however, allows users to take close to small to naked eye individual cells. Specimens are usually small and have some degree of transparency. Because compound microscopes are relatively inexpensive yet useful. Yes, that is why it is being used in the laboratory, in the science lab. They are used everywhere, from research labs to high school biology classrooms. Any questions so far? Grade 7? Again, grade 7, turn on your camera so that I can see you. Okay. So these are examples of microscopes, the compound microscope. The one in your right is a binocular electric compound microscope because it uses a bulb. And the one in your left is a compound light microscope, monocular compound light microscope because it uses a mirror as an illuminator. Let's move now to the stereo microscope. Stereo microscope is also called a dissecting microscope. By the way, this microscope is being used in dissection. Are you familiar with dissection? What comes into your mind when you hear the word dissection? Yes. Anybody? Again, what comes into your mind when you hear the word dissection? Anybody? Okay. Oh, injection? No. Dissection meaning to say that you cut open something or you cut open your specimen. That's to dissect, right? So this stereo microscope is being used. Would you still hear me?
Yes.
All right. Again, this microscope is being used for dissection. Provides multiplication up to 300 times. Yes. This binocular microscope are used to look in at opaque object or objects that are too large to be viewed with a compound microscope. Yes. Macroscopic specimens. Since they do not require slide preparation, just like your light microscope, your compound light microscope, although their magnification is relatively low, they are still useful. They provide a close-up 3D view of objects, surface, textures, and they allow the operator to manipulate the object during viewing. Stereo microscope are used in biological and medical science application as well as in electronics industry, such as by those who make circuit boards or watches. So this is your stereo microscope. Have you seen this one? If you're going to repair shops, like going to SM and you want to repair your phone, you can see stereo microscopes there. Are you familiar with this? Grade 7?
No.
Question so far?
None.
Question so far? Let's move now to confocal microscope. Unlike stereo microscopes and compound microscopes, which use regular light for an image formation, confocal microscope uses a laser light, right? Again, confocal microscope uses a laser light to scan samples that have been dyed. Dyed meaning to say stained. Please let me know if there are some words that you find it hard to understand so that I can unlock it. All right? Are you still with me?
Yeah.
Yeah.
Okay. Again, please tell me if there are some words that you find it hard to understand so that I can unlock it. Yes, a real laser. These samples are prepared on slides and inserted. Then, with the aid of dichromatic mirror, the device produces a magnified image on a computer screen. Again, this is computerized, by the way, because we're using a laser light. Operator can create 3D image as well as by assembling multiple scans. Like a compound microscope, this microscope offer a high degree of magnification, but their resolution is better. They are commonly used in cell biology and medical applications. We I am done using this confocal microscope before in our science lab because we usually use this for higher magnification, like looking at the cell, looking at the nucleus, or looking at the DNA. This is your confocal microscope. Again, it uses a laser light at the same time. It actually records the image in the computer. By the way, if you're going to look at it at the back, it's a computer. Okay? It will automatically register those that are scanned in your confocal microscope. Let's move now to scanning electron microscope or the SEM or SEM. Scanning electron microscope uses electrons. Okay, again uses electrons rather than light for image formation. Samples are scanned in vacuum or near vacuum conditions. So they may be specially prepared by first undergoing dehydration, then being coated with a thin layer of conductive or conducive material such as gold. After the item is prepared and placed in the chamber, the SEM produces a 3D image, black and white image on a computer screen, offering ample control over the amount of magnification. SEMs are used by researchers in the physical, medical, biological sciences to examine the range of specimens from insects to bones. Again, your scanning electron microscope uses electron to create an image, right? So this is your scanning electron microscope. And this is the output. These are the outputs. As you can see, you, these are bacteria, by the way. These are bacteria, the upper portion, okay? It is Streptococcus, Streptococci. Any questions so far? Questions so far?
No.
Are you sure? Let's move forward to transmission electron microscope or TEM or TEM. Like the scanning electron microscope, the transmission electron microscope uses electrons in creating magnified image. Correct, same. And samples are scanned in a vacuum so they may specially prepared. Unlike SEM, however, TEM uses slide preparation to obtain 2D view of the specimen. Again, TEM or transmission electron microscope uses a slide preparation to obtain 2D view of the specimen. So it is more suited for viewing objects with some degree of transparency. A TEM offers a high degree of both magnification and resolution, making it useful for physical biological sciences, metallurgy, or the study of metals, nanotechnology, and forensic analysis. So this is your TEM, okay? As you can see the chamber there, right? Okay, let's move now to the parts of the microscope. But before anything else, do you have any questions so far? Questions so far?
None.
Let's move now to the parts of the microscope. Start with the ocular or eyepiece. This is where you look at or look to view the object placed on the stage or to view your specimen. Okay? If this is your microscope, your ocular is actually placed on the topmost. Okay? This is your ocular. This is where you can actually see your specimens. Next is the body tube. Now, your body tube supports the eyepiece and the lenses. Okay? Again, your body tube supports the eyepiece or the ocular and the lenses because it is your eye tube, your ocular is connected to your eye tube and your lenses also is connected to your eye tube, to your body tube rather. So if this is your microscope, this is your body tube and this is your lenses. It is directly connected. That is why. Next is the coarse adjustment knob. Okay, this knob is for larger focusing. Like if you're looking at your microscope, this is your coarse adjusting knob. Okay. Next is the fine adjustment knob. This knob is for precision focusing, meaning to say if you've gone with your specimen, if you already focus your specimen and you want it to clearly see your specimen, you use the fine adjustment knob. You can also use the fine adjustment knob if you are using the HPO or the high power objective or the OIO oil or the oil immersion objective. So this is your fine adjustment knob below the coarse adjustment knob. Next is the revolving nose piece. This is the revolving section that carries the objective lenses. Okay. Now, if you're going to look at your microscope, your revolving nose piece holds again your lenses in place. And again, this revolving nose piece actually turns your lenses, or you can switch your lens from low power scanner, high power, or OIO. Objectives. This has 3 or 4 lenses. Again, the scanner, the oil immersion objective, the low power objective, or the high power objective. Any other question? Question so far? Grade 7? Question so far?
None.
Are you sure? Okay, we still have 6 minutes left. Let's move now to the arm. This is the basic frame to which the base, body, and stage are attached. So if you're going to look at your microscope, your arm is actually holding the body tube and your base. Okay? Your arm also can actually tilt the entire microscope if you're using a light microscope. Stage. This supports the microscope or microscopic slides. Again, your stage has a clip. Okay? Stage. This is the area where you can put your prepared slides or your specimen. Stage clips. It holds the slides in place. Like if you're going to put your specimen on the stage, you need to clip your specimen in place. So that is why there is a stage clips there. Inclination joint. This is the tilting part of the microscope. So if you're going to look at your microscope, below your arm, you can see the inclination joint because sometimes you need to tilt your microscope to gather more light, or you need to tilt your microscope for your viewing. Okay, the angle of your viewing. Diaphragm. This is the wheel-shaped device that regulates the amount of light passes through the specimen. If you're going to look at your microscope, the diaphragm is below your stage. As you can see, the diaphragm, you can adjust the light coming from the outside source, all right? Came from your mirror or came from your bulb. You can adjust the light through the diaphragm. Okay, you can close and open the diaphragm. It depends upon the need of the light. Mirror. It reflects the light to the lens of the microscope. Again, we have 2 types of mirror here, the concave and convex. Concave, if you're using a natural light. Convex, if you're using a bulb or using an outsource outside light or external light. Again, below your stage, you can see the mirror if it is a compound light microscope. But if it is an electric microscope, which uses bulb, you cannot see a mirror there because you're already provided with a bulb as your illuminator. Again, base supports the microscope. So these are the basic parts of your microscope. Any other question or any questions that we need to, to clarify, to unlock? Grade 7? Question so far? Are you sure? Are you really sure? Did you understand the topic? Did you understand the topic? Grade 7? Did you understand the topic? Sure. So I will give a quiz by next meeting. Is that a deal? Shall I give a quiz by next meeting? Grade 7? Okay. I think that would be all for today. Thank you for listening, and hopefully you'll be answering your activities because I cannot give a grade without an output. I'm really sorry. Again, it's up to you. It's up to you to decide whether you will answer your activity or not. I am not a typical teacher that allows students, you know, to have a grade without an output. No, that's a big no-no. Aside from that, I am a teacher with deadlines. So you can ask my previous student. And again, do not insult my subject. Am I making that clear? Grade 7? Okay. Let's make it clear as early as now, right? I think that will do all for today. Thank you for listening. And hopefully by next meeting, everybody will open their camera, right? Am I making that clear?
Yes.
Right. So thank you for listening. Have a nice day ahead. Bye bye.
Bye, chair.
Hi, Joe.
Bye bye. Take care, everyone.
Thank you. Have a good day.
Right.